This week's lesson is going to involve probability of simple events, or simple probability. This comes from the lesson 9.1 guided notes. Just as a reminder, you should either print out the lesson 9.1 guided notes and copy these in, or if you don't have a printer that works, you can copy this down on paper. That way you can go back to these examples later. I'm going to ignore the top part of this where it says outcomes, see textbook page 711. It's not the most important screen to take a look at. Some of you may have your books at home, some of you may not. It's not something we need to see. So we're going to go right into some key vocabulary for probability of simple events. A simple event is one outcome or a collection of outcomes or results. Some examples include choosing a Scrabble tile, selecting a card from a deck of cards, rolling a die, choosing a number from a set of numbered cards. Something like that is going to represent a simple event. A lot of probabilities that you're used to working with, we're going to see a lot of questions that involve selecting a marble from a jar. Those are simple events. Now, you've probably seen probability before, so this lesson I think you'll find to be relatively simple. It's nothing super complicated, but the probability of something is the chances of an event happening. Now, this may be new for you, this format we use here. It says P and then in parentheses event. That means probability of some event occurring. If it says P in parentheses blue, it might be the probability of selecting a blue marble, for example. If it says P and then in parentheses hearts, it might mean what's the probability of selecting a card from a deck of cards that has hearts on it. So when we say P and then in parentheses event, it's just the way we represent finding the probability of some event. Your total number of outcomes is always going to go in the denominator. So a lot of times what we'll be doing is adding up the total number of cards we have, adding up the total number of marbles we have. One of the questions we're going to be adding up the total number of donuts that we have. The top number is the number of favorable outcomes. So if we have P and then in parentheses blue, it's the number of blue marbles, for example, that you have. If we're talking about Skittles and we say P yellow, the probability of selecting a yellow Skittle would be the number of yellow Skittles we have out of the total number of Skittles. So we will represent probability as a fraction. We'll also represent it as a percent, because a lot of times we do see probabilities written as percents. Like, for example, if you go onto the Weather Channel app, they will have the probabilities of it raining at any different hour, any hour throughout the day. That's a probability. Now, the probability will always be between 0 and 1. That's important for us. The closer the probability is to 1, the more likely that event is to happen. In fact, if it has a probability of 1 or 100%, it means that that event is definitely going to happen. The closer the probability is to 0, the less likely it is to happen. So if something has a probability of 0, it means that it is impossible and will not occur. When something has a probability of 1/2, it's as likely to happen as to not happen. So it's a 50-50 shot. You sometimes hear that quite frequently. Again, closer we get to 0, the less likely it is to happen. The closer we get to 1, the more likely that event is to happen. You can probably hear my son in the background. He's not happy that he can't be in the same room. So let's do some examples. So one of your assignments for the week is going to be to complete some simple probability questions. And again, I do think that they're pretty easy. Please remember that I will hold office hours on Thursdays at 10 from 10 to 11, and then again at 11 from 11 to 12. So if there are things that you have questions on and you want to ask on Thursday, feel free to get onto Zoom, which I have the links on Canvas. Feel free to get into Zoom and ask those questions. And you can email me at any point throughout the week with questions as well. So our first set of examples, it says a bag contains 5 red marbles, 5 blue marbles, 6 green marbles, 8 purple marbles, and 1 white marble. 1 is selected at random. That's important for us because the probability changes if we don't do that at random. Find the probability of each outcome. Express each probability as a fraction and as a percent. That's important for us to remember. If it asks us to do that, make sure we follow those directions. Some may not say that you have to write it as a percent, so then we don't need to do that. this first set of problems does. So the first question you want to answer is, how many total marbles are there? So take a moment, count up how many marbles we have. Okay, hopefully you got the same sum that I did. We have a total of 25 marbles. So number one is asking us, it says P parentheses white means what's the probability that we select a white marble? Well, going back to the directions, we have one white marble out of the 25 total. So that probability will be 1 out of 25. Now you're going to notice I have 4% next to this. You might wonder, where did she get 4% from 1 out of 25? Well, first, since the denominator is 25, I can multiply the numerator by 4 to get 4 out of 100, and the denominator by 4 as well. 4 out of 100 is 4%. You could also do 1 divided by 25 in your calculator, not 25 divided by 1. 1 divided by 25 will get us 0.04, which is 4%. Number 2, we want to find the probability of selecting a red marble. Well, in our directions, we see that we have 5 red marbles out of the 25 total. So that probability is going to be 5 out of 25. We can plug that into our calculators and hit equal. It should reduce it to 1/5, or divide top and bottom by 5. 1/5 is equal to 20%. And again, I could multiply 5 by 4 to get 20 out of the 100, which is 20%. It's nice when we have denominators like 10, 20, 25, 50. Those are easy to change to percents. Number 3, what's the probability of selecting a green marble? Well, in our directions, we see that we have 6 green marbles. So we're going to write 6 over 25, multiply top and bottom by 4 to get 24%. Remember, you can take 6 divided by 25, which is 0.24. That is 24%. All right, our next set of examples, so these are the same directions. I just copied them to the next slide so we could refer to them. So number 4 says P purple. What's the probability of selecting a purple marble? Well, we have 8 purple marbles out of 25 total. 8 out of 25 is equal to 32%. It doesn't reduce, but if we multiply 8 and 25 both by 4, we get 32 out of 100, which is 32%. Now, those are pretty easy questions. Let's shift into some that are a little bit more challenging. Number 5 says P and then in parentheses, not red. So that would be blue, green, purple, or white. So what I do is I add up how many blue, green, purple, and white marbles we have. That's 5 plus 6 plus 8 plus 1, which is a total of 20 marbles. So 20 out of 25 are not red. That reduces to 4/5, and that is 80%. What's the probability that it's not green? Well, we add up the red, the blue, the purple, the white, which is 5 plus 5 plus 8 plus 1, which gives us a total of 19. That's 19 out of 25, which is 76%. All right, so same directions again. Number 7, what's the probability of selecting a green or purple marble? So that when I select a marble, it's either green or it's purple. What we want to do is we want to add green to purple. So we do 6 plus 8 to get a total of 14. 14 out of 25 is 56%. Number 8, what's the probability of selecting green, purple, or white? So we have 6 green, 8 purple, 1 white marble. We'll add those together to get a total of 15 marbles. Out of the 25 we have, that reduces to 3/5, which is 60%. Number 9 is asking us to give an example of an impossible event. It means it has a probability of 0. It means it cannot happen. Stop a moment and think, what would be an example of an impossible event using the same situation here? So one example I came up with was the probability of selecting a brown marble. Now you don't have to write selecting a brown marble. You could just put P and then in parentheses brown. We don't have any brown marbles, so that's an impossible event. It can't happen. You may have chosen a different color, but that means it would be something that is impossible. If we're also looking for something where we have a 100% probability, we would say, what's the probability of selecting a red, blue, green, purple, or white marble? All right, so shifting gears into more word problem types of questions. It says a jar contains marbles as shown in the table below, or off to the right here. Number 10 says, what is the probability that Brandon will select an orange marble or a green marble? Write your answer as a fraction in simplest form and as a percent. Well, we need to figure out how many total marbles we have. So we add 15, 13, 15, and 7. That will get us a total of 50 marbles. So if we're looking at orange or green, we're going to add 15 and 7 together to get a total of 22. 22 out of 50 reduces to 11/25. That is 44%. 11 and 12 are true and false questions. I actually really like these problems a lot. Number 11, it says true or false. Brandon is equally likely to select a red marble as he is to select a green marble. Well, take a look. We've got 15 red marbles. We've got 15 green marbles. This is true. We have the same number of red as green marbles. Therefore, those two events are equally likely to occur. Number 12, true or false? Brandon is less likely to select a blue marble as he is to select an orange marble. Well, we have 13 blue marbles. We have 7 orange marbles. It's definitely not less likely to select a blue marble since we have more. This is false. He has more blue marbles than orange, so it is more likely that he will select a blue marble. Now, does that mean that he's going to select blue more than orange? Not necessarily. Experimental probability, we'll talk about next week, may differ from what we call theoretical probability, meaning what we actually have in this jar or container. But based on the numbers we have, it is more likely that he will select a blue marble. All right, so we have a couple of word problems here. Number 13, a cube is painted on each side. 3 sides are green, 2 sides are yellow, and 1 is purple. What is the probability that, when it is rolled, it will land yellow side up? Write your answer as a fraction in simplest form. Well, a cube has 6 sides. 3 green, 2 yellow, 1 purple. The probability of it landing yellow side up, well, 2 of the sides are yellow. I'll go ahead and highlight that in yellow. So it'll be 2 out of 6, which reduces to 1/3. As a percent, that's 33.3 repeating percent, but it doesn't ask us to write it as a percent. Number 14, a teacher is distributing donuts to her 20 students. She has 8 glazed, 5 chocolate frosted, 6 vanilla frosted, and 1 cinnamon sugar donut. Lily does not like chocolate or vanilla frosted donuts. What is the probability that Lily will get a donut that she likes? So this is kind of funny since we actually just had donuts this morning. Really, I should attach a picture of my son because he had a mouthful of sprinkles as well. He was really sugared up this morning. But definitely a good question for us because it gets to a more real life situation. First of all, we need to figure out how many total donuts we have. We do have 20 students. We want to make sure we actually have 20 donuts. So we add these up. We've got 8, 5, 6, and 1. That's going to total to 20 total donuts. Now, we're trying to find the probability that Lily will get a donut that she likes. So we know that she does not like chocolate or vanilla frosted donuts. So I'm going to cross some things out here. So I'm going to cross out the chocolate frosted. Whoops, I got this. So we're going to cross off. Oh, I don't know why that keeps happening. Let's cross off the chocolate frosted and the vanilla frosted. We need to get rid of this 5 as well. There we go. Looks like it'll let us do that. Since she doesn't like those 2 types, this means she does like glazed and the cinnamon sugar donuts. There's 8 glazed, 1 cinnamon sugar for a total of 9. Since she does like those, we have a total of 20 donuts. So this is going to be 9 out of 20. 8 plus 1 is going to be 9/20. If we want to write that as a percent, that would be 45%. Again, we just need to read carefully because it says Lily does not like chocolate or vanilla frosted. We exclude those, just include the 8 glazed, the 1 cinnamon sugar for 9 out of 20. All right, let's move ahead to our last set of questions. And then what I did is I put some independent practice in the video for you to try. Then we'll go through them. So in this set of problems, it says 10 cards numbered 1 through 10 are mixed together and then one card is drawn. Find the probability of each event. Write your answer as a fraction in simplest form and as a percent. P6. Now, it's not going to be 6 out of 10. We do have 10 total cards. A lot of times students want to write 6 out of 10, but it's the probability of selecting a card that is numbered 6. There's only one 6 out of 10, so this will be 6/10. Sorry, 1/10. Goodness, I'm getting distracted here. I can hear my kids. We have one card out of 10 that has a 6 on it, which will be 1/10, and that will be 10% for us. Number 16, P8 or 9. We have two cards that are numbered 8 or 9. So since we have 2 out of 10, this is going to be 2/10, which reduces to 1/5. That is 20%. It's really easy when we have a denominator of 10. You can just multiply your numerator by 10 to get what your percentage is. Number 17, it says P odd. What's the probability that we select a card that is an odd number? Well, that's going to include numbers like 1, 3, 5, 7, and 9. That's 5 of the cards out of the 10 that we have. 5/10 reduces to 1/2. That is 50%. Hopefully you can't hear my son crying in the background. He's really mad that he can't come in the room and disturb us as we're making this video. All right, same directions for the next set of problems, numbers 18, 19, and 20. So number 18, probability of a less than 5. So selecting a card that has a number on it that's less than 5. That does not include 5. So that will be numbers like 1, 2, 3, and 4. So that will be 4 out of the 10 cards, which reduces to 2/5. That is 40%. Number 19, what's the probability that we select a card that's not 6, 7, 8, or 9? Remember, not any of those. So that means it could be 1, 2, 3, 4, 5. Don't forget about 10 though. That's a total of 1, 2, 3, 4, 5, 6 out of the 10 cards. 6/10 reduces to 3/5, which is 60%. The last one here is kind of tough. What's the probability that the card we select is divisible by 4? Well, between 1 and 10, the only two numbers that are divisible by 4 are 4 and 8. 4 divided by 4 works out to be 1. 8 divided by 4 works out to be 2. So it's 2 out of the 10 cards, which will be 1/5 or 20%. All right, so we've got a ticket out of the video. Woo for virtual learning here. So I put 3 questions together for you to try, so you may want to pause the video, and in just a moment we'll go through these. All right, so it says find the probability of each of the following events. Write your answer as a fraction in simplest form and as a percent. Hopefully you paused the video and gave these problems a try someplace on your notes or someplace on paper. A jar contains 5 blue, 8 green, 4 yellow, and 3 purple marbles. So we have a total of, when we add these up, 20 marbles. 5 plus 8 is 13, plus 4 is 17, plus 3 is 20. What's the probability of selecting blue? Well, 5 are blue out of 20, which reduces to 1/4. That is 25%. Number 2, what's the probability of selecting green or yellow? Add the 8 green to the 4 yellow to get 12/20. That reduces to 3/5, which is 60%. Number 3, what's the probability that the marble that's selected is not blue? Add the 8 green, 4 yellow, and 3 purple to get a total of 15 marbles. 15 out of 20 is going to reduce to 3/4, which is 75%.